Good afternoon. This is MCS Geometry, Saxon Geometry Lesson 75, page 495 in your textbook. I really like this. This is the equation of a circle. You will, at the end, be able to graph any circle given its equation, or be able to determine the equation of any circle given its graph. But let's start with the warm-up. Please pause and answer the warm-up questions. You're back. If P is a point on circle Q, then PQ is a blank of the circle. I hope you said radius. Sure you did. If circle A is centered at the origin and has a radius of 2, name 4 points that lie on circle A. Hint, 2 of the points are on each axis. So if it's centered at the origin, it has a radius of 2, 2, 0, 0, 2, minus 2, 0, and 0 minus 2 are 4 points that lie on that circle. Multiple choice. Which of these numbers are possible values of A, B, and C in the equation of a squared plus b squared equals c squared? Well, we recognize that as the Pythagorean theorem, and we can try out 4 squared, which is 16, plus 5 squared, which is 25. You get 41 squared. Well, that doesn't equal 64. But we might scan and look for answer B. I'm going to come down here. And remember that 3, 4, 5 is one of our special whole number triangles. So B will satisfy it. And make sure that you have put 3, 4, 5 down on your smart sheet as a special triangle side, because you might see 6, 8, and then you automatically know that 10 is your third side for that triangle when you memorize that 3, 4, 5 is special triangle. Let's go on to writing the equation of a circle on a coordinate plane. Well, we start with circle C with the center at the origin. So here's the center at the origin of C. And I wrote C right here over at the origin. C has a radius of 1. So I came out all the way to 1. That gives that point intersection of 1, 0. It gives this point of intersection of 0, 1. Because this point of intersection is minus 1, 0. And down here, point of intersection of 0, minus 1. I sketch in the 4 points that I'm aiming for, and then just give a rough circle. Now, if we're coming all the way over here, with this point right here can be represented by its x-coordinate and its y-coordinate. And its name of that point is P, but x, y is its coordinates. Well, how do we find out the radius then? Or how do we find out? So we know that x squared plus y squared equals c, a squared plus b squared equals c squared. So x squared plus y squared equals the radius squared. And we can call that hypotenuse or that radius CP, segment, or we can call it r for the radius. So x squared plus y squared equals r squared. That is true for that point. We're going to substitute in 1 for r. And we got x squared plus y squared equals 1 for that point on that circle. And that, in fact, is true for any x that you choose, that you'll be able to find where it lies on that circle. Any circle at the origin. So any circle at the origin will be x squared plus y squared equals radius squared. We have the magic case of 1 squared equaling 1 here. Do not be tricked. So now we know a general form for anything circle at the origin. Let's move the circle. Oh no, we shifted it to the right. Oh, we call those isometries. Well, we're doing an isometry of a circle, and we have right here the center, and it is at 2, 0. Well, if we put that into our form of our equation, we say this whole thing is x for this point right here. For our point xy, from the origin out to the 3 is x. But what's its distance for the little triangle? It's x minus the 2. So x minus 2 is this length, quantity squared, plus this is y, and I don't have to subtract anything, y squared equals, and we were told that the radius was 2. 2 squared. So the distance formula, I'm going to go ahead and put the 0 in. X minus 2 quantity squared plus y minus 0 quantity squared, square root of all, equals 2. In this form, the coordinate of the center, which I will call AB, is depicted, and I will put in A and B. X minus A, the x coordinate of the center, quantity squared, plus y minus b, the y coordinate of the center, quantity squared, equals r. So in this equation right here, the center is a, b. You can put that in your smart sheet, but on the next page we'll have a better form. So let's go back to the drawing and compare it to the equation. The center is 2, 0. Be careful to note that in x minus a squared, the a looks negative, but a is the x coordinate. And let's compare that to x plus a quantity squared. This tells us or yields that negative a is the x coordinate. And rewriting that so you see it, it's x minus the quantity negative a all squared. There are two things we can do now. One, we can write an equation from a graph. Two, we can graph a circle from its equation. First, let's look at a graph. We have right here center D. We're going to identify its center by reading the graph over 1, up 3, so 1, 3. Now, this happens to be touching the x-axis, but it doesn't necessarily have to. So we're going to drop a perpendicular down this direction, and we can drop a perpendicular over towards a y line, and we will count 1, 2, 3. We can also do that here, 1, 2, 3. So now we have determined from the graph that our radius is 3. Given the center point and the radius, we can now write x minus 1 quantity squared plus y minus the y quantity squared equals 9, because I already squared 3, or 3 squared. Well, that's very good. Now let's write an equation for a concentric circle called E with a radius of 5. Well, concentric means it has the same center. So none of this part of the equation will change. The only thing that changes is the radius. So here we go. X minus 1 quantity squared plus y minus 3 quantity squared equals, well, now our radius is 5. So 5 squared, which is 25. Now when we turn the page, please make sure that this form goes on your smart sheet. Here we have the x-axis and the y-axis. And a circle. It has a x, the center of the circle has an x coordinate of h. I go over h, I go up k. So since it's the center is hk, I write x minus h quantity squared plus y minus k quantity squared, which equals our radius squared. This is the precise depiction of the equation of a circle you will find fairly universally. I'm not sure about how many other languages, but in all places I've seen, you will see it with x minus h and y minus k and r squared. So please put this on your smart sheet along with what helps you. The center is hk. The r is the radius. So now let's graph a circle when given this equation. Circle P has the equation of x squared plus y squared, which equals 25. We will rewrite it to be in the above form of x minus 0 quantity squared plus y minus 0 quantity squared equals 5 squared. Now we can see clearly that its center is 0, 0, and its radius is 5. When doing any of the graphing of the circles, please use graph paper to set the points. But you may sketch the actual circle, but please then label the center point and the radius. Let me show you. Here's 0, 0. I'm going to come over 5, up 5, that way 5, down 5, and then I sketch in the circle. Then I label the center point P, and I draw in a radius to label the radius. In this example here, we are given the equation x minus 2 quantity squared plus y plus 1 quantity squared equals 16. Ooh, wait a minute. That's not in the same form. Y minus a minus 1 all squared. Now we can clearly see that x minus 2 is our x coordinate. Y minus negative 1 is our y coordinate for the center. And the square root of 16 happens to be a nice even number of 4. So the way that we're going to graph it, now that we've determined our center and our radius, is we're going to go over 2, down 1, and mark the center, and I labeled it Q. We're going to go over 1, 2, 3, 4, horizontally this way, 1, 2, 3, 4, horizontally that way, 1, 2, 3, 4 down, and 1, 2, 3, 4 up. Now I've marked 4 points. If you want, I have also taught that you may take that and draw the box. It represents a box. It just makes it easier then to sketch out and to make your drawing big enough so it resembles a circle. We've already labeled Q. I put in a radius and labeled it 4. But you can see how sketching in the box, putting in the 4 points, then you can sketch your circle. Label Q and the radius. Well, example 4. Let's go on to life. Give the equation of a satellite's orbit around the Earth. Oh my. Well, the center we can determine is 0, 0. Its altitude is 23,000 miles. It's given. So x squared plus y squared equals 23,000 all squared, which they give us in the book is 529 million. Now you can graph any circle or write an equation for any circle. Good job.